there's a collection of different types of analytics and modeling that you can build in data science. And this is just a general snapshot of the current status of the way models are deployed into industry. And you can see here there's a lot going on this chart. But over here is the categories of models. At the bottom you have descriptive modeling. Descriptive modeling is typically represented as some set of data visualization, usually a dashboard, and it represents what happened or what is happening. It's a situational awareness type of modeling. And you can see that it provides some value, but it requires a lot of human input. So you do a bunch of work up front to get the data in place. You do some work building the dashboard, and then it's up to human beings after that to actually decide what to do based on that information and then take action. These are the most straightforward analytics to build. As a matter of fact, if we stopped right here and you only did descriptive analytics, we would be in an industry referred to commonly as business intelligence. And as a matter of fact, most of the times when you hear people refer to analytics today, they're actually referring to business intelligence applications, which are simple visualizations or dashboards of historical data or information. As we move up the line here to different types of models, they become more difficult. They increase in complexity and challenge, and they require different skill sets to implement. So diagnostic, why did it happen? Exploring the data, trying to find causal relationships between components has its own set of techniques and approaches. Then predictive, which we're going to focus most of the rest of the day on in the next couple of chapters. This is trying to predict the future, or more specifically, it's trying to uncover an uncertainty. So trying to find something that you can't directly observe and predict what that value is. Of course, you can imagine how valuable that would be. Then there's prescriptive modeling. Prescriptive modeling takes a prediction and then uses it in a decision model to recommend a course of action. And you can see it recommends a course of action, but it's still up to the human being to actually take the action. And then sitting on the top of this are artificial intelligence techniques, which are mechanisms for automation. So they're basically, a lot of work up front, and then the analytic itself goes all the way through to action. So it actually takes a behavior and an activity that typically would be done by a human and then automates it so that a machine does it completely. As you can see, the set of modeling, as they increase in difficulty, also increase in value. The more significant the complexity in analytic is, if it's successful, it can provide some significant benefit to the organization that's hosting it. So there's different types of modeling approaches. So how do we build these classes of models? I want to draw a distinction right now between two classes of modelers. There's a modeling community that has grown up in the statistics discipline, and there's a modeling community that has grown up in computer science. Most of the mathematics between these two communities are the same, but their worldviews are slightly different. And so what we're going to focus on is mostly the machine learning aspect. So when we talk about the quality of a model or the quality of an application or an algorithm, we're going to be talking about it in the context of a machine learning model, as opposed to a classical statistical learning model or a statistical model in general. It's not to say that statistical models aren't important. As a matter of fact, in any intermediate or advanced data science course, statistical models will be covered in significant depth. But many of the early machine learning models are a little bit more intuitive for beginners to get their minds around, and so that's where we're going to focus. All right, so there's three basic categories of machine learning models. The first is supervised learning, and this is the most common. Supervised learning models are where you have a set of historical data, like we've seen before in our assignments, and you have a historical record of observations that you're attempting to predict. Sometimes you'll hear this called mapping XY pairs, right? So for example, in the Titanic data set, you have all of the features associated with each of the passengers on the Titanic, as well as a flag or a label that says whether or not they survived. So your goal is to predict ultimately whether or not someone's going to survive. And in the supervised setting, you have a historical data set where you actually know if people did or didn't survive. There's also a related discipline called unsupervised learning, where you have historical data, but the data has no labels. And you'll see this is the second most common. Go over here. So in unsupervised learning, you have different techniques where you don't know what the outcomes are. So your goal is actually to look at characteristics inside of the feature set as opposed to attempting to predict something. The most common is clustering algorithms. As you can see here, this quick little picture. The idea is that you have data sets that then they naturally group with each other, and then you can use those groupings to infer some sort of insight about the data. But you don't actually know what these groupings are before you start. It's the feature set itself which yields this type of insight or this type of analysis. And the last type is reinforcement learning. Reinforcement learning is where you have no historical data, and it's the machine's job to learn about the environment simply by interacting with the environment. These are the most complicated sets of models. They become popular. We won't touch on them here in this introductory course, but it's good just to know that they exist.